let's talk about transformations of exponential functions. So the nice thing is these transformations are going to be the same transformations that we've been looking at all along. Nothing really has changed, and so we're just going to now apply them to the exponential function. To start with, can an exponential function be drawn through all three of these points? So let's take a look at this. Okay, so remember we start with our table of values. This point is at 0, 1. This point is at 1 and 3. And this point is at 2 and 8. Now, in order for us to be able to draw an exponential function, we have to take a look at our difference ratio. And so if I look at this ratio, I get 8 divided by 3. And if I look at this ratio, I get 3 divided by 1. Well, 3 divided by 1 is 3, but 8 divided by 3 is 2.67. And so because we don't end up with the same ratio, this is not an exponential. Remember, we always have to be able to find that ratio, that common ratio, in order for something to be an exponential. Okay, let's talk about transformation. So we're going to look at the function y equals 3 to the x. Now, 3 itself is not a transformation. This is your base. Okay, so the 3 is not included when we talk about transformations. All right, so from here we do have a negative sign in front of our 3. That negative sign means that there is a reflection in the x-axis. And for this one, we can see that we're subtracting 5 directly to the x. So that means it's going to be moved 5 units to the right. Remember, when it comes to the x, when it comes to adding or subtracting something to the x, it's always the opposite sign. So that's going to give us 5 units to the right. This has a 5 multiplied out in front. That is a vertical stretch. By a factor of 5. This one has 0.5 multiplied to the x. So this is horizontal stretch because the number is in between 0 and 1. It's a 0.5. It's a horizontal stretch by a factor of 1 over 0.5, which equals out to 2. So it's a horizontal stretch by a factor of 2. We have a couple of things going on here. We have this negative in front of the x. So that negative in front of the x is a reflection in the y-axis. And then subtracting 2 means 2 down. Okay, so we've seen everything. We've seen all different transformations happening there. So let's say we put it together. And what if I had given you an equation like this? So there's lots going on. We got to talk about everything. So the first off, this negative out front is a reflection in the x-axis. And then we have the 4. And the 4 is a vertical stretch. By a factor of 4. And then we have that 2 that's outside the brackets. That's going to be a horizontal compression. By a factor of 1/2, so 1/2. Then we have that plus 3 that's in the brackets, which means it's minus 3 when it comes out, so it's 3 to the left. And then lastly, we have that 7 at the end, positive 7, so 7 up. So lots of transformations that are happening there. 1, 2, 3, 4, 5 transformations. Okay, so notice that our terminology hasn't changed from our previous unit, the one right before Christmas. We're still talking about vertical stretches or compressions, horizontal stretch or compressions, reflections in X and Y axes, and then moving things left, right, up, and down. All right, so how about graphing? So when we graph, what we want to do is we want to actually start by looking at the base. So our base here is a 2, which means I want to graph y equals 2 to the x. So I'm going to go in between -2 and +2. And I'm going to put in the exponent here. So 2 to the -2 is 1/4. So 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. So that's where we begin. And then from there, we want to apply our transformations in the order that they show up. So starting with this 0.5 means that I want to multiply all of my y values by 0.5. Okay, so basically like you're going to cut them in half. So that 1/4, I'm going to change to 0.25. Multiply it by 0.5 and you get 0.125. And then 0.5 times 0.5 is 0.25. And 1 times 0.5 is 0.5. 2 times 0.5 is 1. 4 times 0.5 is 2. All right. And then the next, we have this plus 3 added to the x value. So that means all over here, we want to subtract 3. So -3 minus 2 is -5. Then -4, -3, -2, -1. Perfect. So this gives us our new points at -5, 0.125, and -4, 0.25, -3 and 0.5, -2 and 1, and -1 and 2. All right, so let's plot these points. So -5 and 0.25 is about there, and -4 and 0.25 is about there. And -3 and 0.5 is about there. -2 and 1 is about there. And -1 and 2 is about there. So basically you're coming along and whoops, let me just undo that. It's not a very nice curve and I want a nicer curve. This is harder than it looks, especially when you're using a mouse. Okay, and there you go. All right, and there's our function of f of x equals 0.5, 2 to the x plus 3. Okay, let's keep going. Let's try another one. So -3 to the 2x plus 4. So again, we're looking for our base, and our base is right there, 3 to the x. So I'm going to create my table of values, -2, -1, 0, 1, 2. And I'm going to use 3 to the x. So 3 to the -2 is 1/9. And 1/9 is 0.11. And then 1/3 is 0.33. And 3 to the exponent 0 is 1. And then 3. And then 9. Okay. We have a negative sign right out front, so let's start with that negative sign. So I'm going to multiply all of these by -1, which gives me -0.11, -0.33, -1, -9, -3, and -9. Then I have this 2 to, that's being multiplied to the x. That means I'm going to go over to my x values, and I'm going to multiply everything by a half. So this is going to be -1, -0.5, 0, 0.5, and 1. And then last, I have that +4, so I'm going to add 4 to all of these. This is going to give me 3.89. This is going to give me 3.67. It's going to be 3, negative, or +1, sorry. -3 plus 4 is +1. And -9 plus 4 is -5. Okay, so my new points then are at -1, 3.89, -0.5, 3.67, 0 and 3, 0.5 and 1, and 1 and -5. All right, so let's try to plot these. -1 and 3.89 is about there. And then -0.5 and 3.67 is maybe there. And 0 and 3 is right there. And 0.5 and 1 is there. And 1 and -5 is down here. So it looks like what we have then, excuse me, is something like that. Whew. Okay, and this should kind of make sense because before, when we have our base graph, we always have this x-axis that our exponential function kind of gets really, really close to, but doesn't cross. But see how we've moved it up 4? So now that new, it's an asymptote is the name of it. That new asymptote now becomes right here at y equals 4. That becomes kind of the new line that it gets really close to, but then doesn't cross. Okay, let's keep going. All right, so we have this as our base graph, 1/2. So y equals 1/2 to the x. And again, let's create our table of values. So to the -2, 1/2 to the -2 is going to be 4. 1/2 to the -1 is going to be 2. 1/2 to 0 is going to be 1. 1/2 to the power 1 is going to be 1/2. And 1/2 to the power 2 is going to be 1/4. And then we're going to multiply all these by 2. So times 2, which is going to be 8, 4, 2, 1 and 1/2. And then we want to add 5 over here because we have that x minus 5. So we're going to add 5 over here, which is going to give me 3, 4, 5, 6, and 7. And then lastly, we come to this +4. So +4, which is going to give me 12, 8, 6, 5, and 4.5. Okay, so 3 and 12, 4 and 8, 5 and 6, 6 and 5, and 7 and 4.5 will be our points. 3 and 12 is going to be kind of up here. 4 and 8 is there. 5 and 6 is there. And 6 and 5 is there. And 7 and 4.5 is there. Okay, so what we have then is this function. Whoops, sorry. Not so easy with a mouse. Kind of looks like that. Awesome. Okay, so as you can see, graphing transformations is the exact same of what we've done before. The big thing is determining which function, like which exponential function that you're going to be graphing. So make sure you pull out that base graph first, and then from there apply your transformations. All right, homework. Give these practice questions a try. And of course, if you have any questions at all, reach out to me. Thank you.